Hello and welcome back to Cracking the Cryptic for another dose of Sudoku. And I do want to mention our apps, which are available on the App Store on Android and on Steam, and you can find links to those in the description field under the video if you click on Show More. Also there, the link to our Patreon site, where we have so much extra content. Just yesterday, a video of my Times Monthly Club special Cryptic crossword solve in the puzzle that really gets into the arcane vocabulary, really recherche stuff in the dictionary, so always worth watching me struggle with that one. And obviously recently we've had Reverence Puzzle Hunt, and I've got a few more people to congratulate. We keep on reading out names and they keep coming in, so well done to Nakul Bharadwaj, Derek Bosch, Helen Thurtle and Adam Smith together, Ken Pro, another couple, John Yoon and Genevieve Elich, Mike Ward, Frank Jernigan, and then there was Charlotte Stang, who also, she was a girl who wrote a really nice review of us as a classroom topic, and she wanted to credit her chemistry teacher, Keith Caracca, but he's already entered, Charlotte, so he's done it before. Steve Aparicio and Matthias Skuman-Völker, and congratulations to those people and to Reverend for the brilliant hunt. We will be, at some point, we will be bringing out a solution to the January reward puzzle, which was not that one. That will be coming out in the next day or two. But the December reward puzzle was an incredible Sudoku hunt by Stefan Bura and Akash Jain, who's known as Udukos, and he has written to us with this puzzle, which is a puzzle of the same type as was in the hunt, in fact. This is a product sum killer. Now, normally in a killer Sudoku, you would expect the cages to not contain repeat digits, and that's fine, that's the case here, but you would also expect them to have the sum of their digits in the corner, and some of them do. But some of them don't. Some of them have the product of their digits in this one. And that makes it a little bit more variable and the logic a lot more crunchy, I think. So do have a go at this. There is also one inequality sign, which means that cell is bigger than that one. And that's what we have. Normal Sudoku rules, no repeats within cages, and the numbers shown in cages are either the product of the digits in that cage or the sum. So do give it a go on the link under the video. I'm going to try now. Let's get cracking. And I had expected that there would be cages where we could immediately tell whether they were products or sums. And I mean, I'm noticing there's quite a few of these where there are only 2 or 3 possibilities. 16 cage, for instance, can only be 9 plus 7 if it's a sum, and if it's a product, it can only be 2 times 8. But, well, let's look at this box, which is a bit busy. Okay, and 9 plus 7 or 2 plus 8. Now, we don't know which way it goes. But we do know that that makes this cage a product, because otherwise the sum would be 987 and this couldn't be filled. Right, I'm going to colour products purple, P and P. Sums, though, I haven't got a colour beginning with S, I'm going to make them green. Actually, I can tell the 2 11s are sums because 11's a prime number. Right, so this is a product. I don't know what that tells us. There are 3 possibilities, 2 with a 1 in and 1 without for 24. It could be 138, 146, or 234. Yeah. So if it was 138, that's 7, 9. What happens to this 6 cage? That has to be 2, 4 as a sum. 138 and 2, 4. Okay, that does work. 1, 4, 6. That makes this 2, 3 as a product. Okay, so whether or not this has a 1 in it well, okay, sorry, to put this another way, if this 24 cage has a 1 in it, this 6 cage has a 2 in it. And otherwise, the 24 cage has a 2 in it, and all of that means that this 16 cage cannot have a 2 in it. So that, which I already marked green for reasons I do not know why. I didn't know what it was. I'm sorry about that. I do now know that it should be green. So 7 and 9 is right. That reduces the possibilities in this 11 cage to 8, 3, or 5, 6. And this is a product, and if it's 2, 3, 4, this is either 1, 5 or 1, 6. They both work, one as a sum, one as a product. That's not very helpful. This cell means this 24 cage is not a sum as well. That's a product too. So again, 1, 3, 8, 1, 4, 6, or 2, 3, 4. What happens to the 12? What happens to the 12 is it cannot be a product, because it will either need it always needs a 1 in it to be a product. I've coloured it wrong. Classic. It always needs a 1 in it to be a product. So this would have to be 2, 3, 4, and that doesn't work for the 12 cage. 1, 5, 6 would be the smallest numbers, which multiply to 30. So that is a sum. I don't know how we use that. 2, 3, 4 would make this 1, 5, 6. 1, 4, 6 would make this 2, 3, 7. And 1, 3, 8 would make this 2, 4, 6. There's only one possibility. Whatever, once we determine how this is made up, we know what the digits in this one are, but there is one possibility for each possibility here. That's irritating. What's this 21 cage doing with its 2 digits here? Now, if this is a product, it's 7 there and 1, 3 here because of the 7 in one of those cells. If this is a sum, well, it has to have either a 7 or a 9 in it. It can't be 9, 5, 7 because you couldn't fit 4 out of 5, 7 and 9 in those 4 cells. So it would have to have an 8. It would either be 7, 8, 6 or 9, 8, 4. No, this is great. So it's either got an 8 in it if it's a sum or a 3 if it's a product, and that decides what this 11 cage consists of. It can't have the 3, 8 pair because that would rule out all the possibilities here. Now, that being a 5, 6, it rules a 6 out of here, but still it could be 7, 3, 1 or 9, 8, 4. So that didn't actually fix everything. If there's an 8 in there, I was going to say this is 9, 5, but it could be 2 times 7. Have to keep remembering the product possibilities. I'm so familiar with the cage total possibilities in normal killer. Yes. And in normal killer, this cell would make this completely impossible. But this is not normal killer. This doesn't have to be 9 plus 7. It can instead be 2 times 8. Now this doesn't have a 2 in it. So it has a 1 in it, but it's either 1, 5 or 1, 6. Definitely has a 1 in it, but I don't know whether it's a product or a multiple. Perfect, yes. If this 24 cage didn't have a 1 in it, it would be 2, 3, 4. Then the 12 cage would be 1, 5, 6, and that is now impossible because of this. These 4 cells highlighted in the top row would all have to contain 1, 5, and 6, and that's too many. So this is not 2, 3, 4. It has a 1 in it. The 1 must be in one of those 2 cells because there's a 1 definitely looking at that cell. Now there must be a 2 in this. It's either 237 or 246. So it's definitely got a 2. And 2 is now confined to rows 1 and 2. Sorry, what I mean is 2 has been used up in these 2 cages in rows 1 and 2, because this one's definitely got a 2 in it, that one clearly has. So this 10 cage does not have a 2 in it or a 1. So it's now, it can't be a multiplication, it's either 3, 7 or 4, 6. It's definitely an addition. Oh, well, which way round does this work then? Yeah, whichever this cage is will determine what this is. Oh, where does 9 go in the top row? It doesn't go there in that product, so it goes here. Maybe some of this would be best done by working out which digits are left over. Now, if this was 1, 6, that would be 3, 7. This would be 2, 4. That would be 8, and this would be 5, and that is not possible. Okay, the question to ask is, can this cell be a 5? And it can't because of this product of 24. Therefore, where does 5 go in the top row? Well, now it goes in this cage. So let's take out the pencil mark and especially take out the 6 possibility. That is now 1 plus 5. I'm going to colour it green as well to keep the colouring going. Oh, and that didn't actually resolve what this is. I thought it was going to, sorry. 5 and 9 are now in these cells in box 1. Two has to be, no it doesn't. Oh, I don't know quite what I'm looking at here. Right, that 2, 8 has ruled out 8 from that cell. So if this is an addition, a sum, the 8 is there. That doesn't get any parsnips buttered. Oh, I'm going back to look at this. If this was, and maybe it matters what this is. If this was 1, 3, 8, this would be 2, 4, 6. This would have to be 3 and 7. That could be 8 though. Ah, there's a problem I think. If this was 2, 4, 6, this would have to be 3, 7. Now I can't see what's going on there. Something is happening here and I can't quite pin it down. I'm sorry. There is definitely something good for me here. Maybe this has to be not a 2. Definitely not a 2, because there can't be a 2 in this cage. So the 2, oh, I don't know. I can't work it out. Sorry. I don't know where else to go in this puzzle though. So if this is 1, 4, 6, there we go. 1, 4, 6 is not possible here. And I'll try and explain why. If this is 146 in the purple 24 up here, this green cage is 237. Now that means that either 3 or 7's in the top row. This cell would have to be 4, 6. And suddenly this cell couldn't be any of 1, 4 and 6 because 4 and 6 are looking at it and 1 from there. So this is not 1, 4, 6. Wow, that took some doing. This is 1, 3, 8 without a 1 at the top. This is now 2, 4, 6. This is 3 and 7 because we've got to fit a 7 in at the top. That is now 8. Right, this is all coming now. 2 and 8 there. 2 is not up here. And it is instead in that cell. And that has an impact down here. This is now either 1, 5 or 1, 6. Because it can't be 2, 3 or 2, 4. So I don't know whether it's a sum or a product, but I do know the 1 is there, and that fixes this cage, which can't be the multiplication anymore. Must be an addition of 9, 8. What's happening there? 9, 8, 4. 17, 21, with 2 and 3 to go in here. No. Yes, that's right. Wow. Okay, that took some doing. This can still be 9, 5 or 2, 7. That's annoying. This thing now. Oh, it doesn't have a 1 in it. It's 2, 3, 4. The 3 is in one of those two cells, so the 3 down here is there. That's a 2, 4 pair. These are from 5, 6 and 8. Crikey, that was a really complicated deduction for me. I'm sorry. Right. Now, where else? Yeah. Oh, yeah, look. This can't be 2 times 3. It also can't be 2 plus 4 because of that 2. So, because of that cell, which won't allow this to be both 2 and 4. So it's got a 1 in it, and it's either 1, 5 or 1, 6. Those tell us where the 1 is, or they tell us where the 5 and 6 aren't. So I don't know what type it is, just like this one, but I do know there's a 1 there. Therefore, there's a 1 in one of these cells. This one can't be 1, 5 because that would be impossible. It now can't be 1, 6 because there'd be 4 cells in the column with a 1 in. So it's got a 2 in it and either a 3 or a 4, which makes a triple with that, which isn't a 2. That is now a 3. Oops. That only is now a 3. So the 2 in the row is there. Now there isn't a 3 in it. It is 2 plus 4, which is green for an addition. So 4 is up here somewhere. I think that's right. 8 is here. Look, we've got 8 there and there. So 8 in column 7 has to be there, but this can still be a multiplication as well as 3 different additions, I think. This cell sees 8, 1, 3, 2, 4, 9, so it's 5, 6 or 7. 2 and 8 are both confined into these cells by the pairs up here. What's this? 12. It can't be 5, 7 as an addition, and it can't be 2, 6 as a multiplication. So it's either 3 times 4, or 3 plus 9, or 4 plus 8. Ooh, that's quite a restricted number set. Don't know. 2, 4, 8, 3. Come on. What are we missing? Sorry, I feel like I ought to be in speed mode. 2. Yes, look, 2 there. I was just going to say, I've been doing the World Puzzle Federation Sudoku Grand Prix round 1 today, so I got used to just trying to go as fast as I could, and it gets irritating then when I get slowed down. Now, because 2 is there and in one of those, it has to be in this cage, which therefore is a multiplication and is 2 times 7. Now 9 has to be here, I think, doesn't it? Yes. I'm in the wrong mode there, so let's go back. 9 there. That puts 1 here. 5, 6 pair on the bottom row. That sees that, which becomes an 8. Now we've got a 5, 6 pair. We've got a 9 looking into that cage, which becomes 4, 8. Yes, this is coming now. This is good. Okay. I feel a bit more like this morning. 2, 4, 8, 3, 5, 6, 1. This is a 9, 7 pair. 7's there and there. One of these is a 7, which probably won't help. This can't be 3, 5, but there's 2 multiplications as well as 2 more possible sums. Seven is in one of those. Oh, hang on. 8, 2, 4, 8, 3, 9 and 1, 5 there means this is a 6, 7, a naked pair effectively. So that becomes a 5 at the bottom with 6 there. That doesn't resolve this one at all. Don't know why I thought it would. That is now an addition. 3, 5, 7 are the remaining numbers here, but this is in a box with a 5 and a 7 already, so that's a 3. 5, 6. This is 4 and 9 now. The 5 down here has resolved the 1, 5 up here, so we've got 1, 6 or 3. So what's happening in this 16 cage? Still the multiplication is possible, 2, 8, 1, so is 7, 8, 1. Three, 8, 5 and 6, 8, 2. Oh, how frustrating. Okay, they're all still possible. Now, what is going on in this cage? It can't be 3 plus 5 anymore. It can't be 2 plus 6 either, because 6 is definitely in one of those cells because of column 3. So it could be 1 plus 7, maybe. Or it could be 1 times 8 or 2 times 4. That's quite a few possibilities. However, they only allow one of 1 and 2 to be in there. And from the other positions of 1 and 2, that must be a 1 or a 2. Oh, that can't be 8. No, that doesn't take 1 out of that cell because it could be 1, 7. Oh, okay. Oh, that 3 is looking straight across there. So that's sorted out. That 1, that gives us a 1 in one of those 2 cells, which we can't really use. Now, what else is going on that I'm not picking up on? Still don't know what that is or how to resolve those. 2, 4, 5, 7. All of those are possible. That's very annoying. Right, if this was 5, 6, that would be a 1. It's not telling me anything, I don't think. If it is, I'm just not thinking it through, which is possible. Oh, so much done and still no real idea how to progress. 2 and 8, they're not really. Oh, that can't be a 2. 2 is in one of those, but that's not significant at this stage. This 16 cage, I haven't really considered it, but there's one multiplication and several possible additions. Quite a few. At least in this one we know there's an 8 in it. So this is the one to focus on, surely. 8. If that was the 5-6 pair, that really reduces the possibilities here, doesn't it? That makes that a 1. This can be 2 or 7. 9, 1, 8, 5, 6. Oh, I can't quite see how to use that. That feels very, very close, but not enough. Not enough. So these are 5, 7, and 9. That's clear. Ah, that's a 5, 7, 9 triple. Right, I should have done that a long time ago. Sorry. 6, 5 there. We know that's an addition now, so I'm going to colour it. 5, 7, 9 triple takes 7 out of this cage. Now it can still be 8, 1, but that can't be a 1 anymore. Now, look at that, my God. Okay, if this was a 1 now, that's really interesting because that would take 1 out of this cell, put it into this one. You'd have 1s in those two. The 1 in the central box would have to be in row 5, but it can't be here because of this 1, and there's no way to put it in a 12 cage with these rules. So that is not a 1. This is an addition, definitely now. I can't be with a 7, and therefore it's either with a 5 or a 6, and suddenly this cage is resolved. Good grief. Oh, that's very pretty, actually. This can't be a 4 now, so that's not a 2. So now we've got a 1, 2 pair. Oh, that 6 has been looking up at that 4 all the time. Oh, if that made all this straightforward, then I didn't need that last bit, but never mind. It's all done now. That's an 8, that's a 1, that's a multiplication. Still got 2 cages to resolve in terms of whether they're sums or products, but that's fine. 2, 8, 1, 7 and 9 are gone from there. 5, 6, 4 is here, 3 is here, 9 is here. That's a 7. 5, 9 pair at the top. This is now a 6, so it's 6, 8, 2 to add up to 16. 5 in the middle, which fixes the 6, 5 cage. 4 has fixed the 8, 4 cage, nothing else there. Now, I'm either going to look at this or this column. That's 6 or 7, and that didn't get me far. So, this 12 cage can't be 4 times 3 or 6 times 2. It can't be 8 plus 4 or 7 plus 5, so it's 9 plus 3. We get the inequality sign to tell us which way round that goes, which doesn't sort out much. Actually, it does. Yes, it does. That's a 1, that's a 3. That was a triple that we could have resolved more of. 9, 3, 4, 5, 2. So this is 6, 7, or 8. 1, 7, or 8. That's not 8. Now, this 16 cage is the last thing that we can use. How are we meant to be using it? Oh, look, that 6, 7 pair's been resolved. That means 6 is in one of these cells. That's not helping. I'm trying still to shortcut this without having to consider all the possibilities. 3 there has resolved 7, 3. That resolves 7, 9. Actually, yes, things are getting a little bit more straightforward. 1, 2, and 8. That is a naked single 1, which makes that an 8 and that a 2. And now this has to be a 6. It could have been a 1, but we've had the 1. That and that, they're both sums. So there ended up only being 5 product cages, but my goodness, they made this harder than if we had known it was what those were, and if this was a normal killer only. 4 and 8 to go in the top, yes. 4 and 9 there. That fixes 5 and 9, and we have a 5 and a 6. And hopefully that is the right answer. Looks good to me. So there we go. I hope you did have a go at that. I mean, another near enough 30-minute puzzle. Very good fun. Really entertaining stuff from Akash there. We are grateful to him still for the puzzle hunt. There was a very good killer with some product rules as well in that, if you want another of these, and why not. So thank you very much for watching as always, and hope to see you again soon. Bye for now.